Yep.
So the evolution of the innovation, when we started in 2008 in the Power Lab at Ottawa U, we started with this 2-coil version. We were able to deliver, 10 watts to the load, maybe 1 amp current. The innovation progressed, 2010. The evolution of the 2-coil prototype went to 1 coil, still, about 1 amp and not commercially viable. And now we are at the point where we have commercially manufactured coils. This one's good for 10 or 20 amps to 60 amps to 100 amps. Okay, we're not delivering 100 amps from this coil because we would need stronger magnets. But the point is that coil is a regenerative acceleration coil that's commercially manufactured, that is able to scale up and deliver 100 amps. So if you can go from 1 to 100, you can go from 1 to 1,000,000. That's what we needed to demonstrate that for ourselves. And
That's just in the change of the coil.
well, in this the scaling up of the windings to handle more current. But the design of the coil stays the same. And the question that we needed to answer as we went through development was, do we lose the regenerative acceleration effect at a certain point? We didn't lose it at 20 amps, we didn't lose it at 60 amps, we didn't lose it at 100 amps. In fact, the effect is more pronounced the more current you deliver.
Interesting.
Okay? So
That's
that's the commercialization readiness aspect. So when you, and our coil manufacturers in Toronto at Toroitech. So now what I'm going to demonstrate is the ReGenX coil, where we're converting the output to DC and we're going to charge a battery. Okay? And so what I'm going to do basically with this prototype is I'm going to operate it above the critical minimum frequency of the coil, and we're going to see regenerative acceleration. The educational tool aspect of this is above the critical minimum frequency and below. Above you'll see regenerative acceleration, and below you'll see regenerative braking. Okay, so below you'll see conventional coil operation, and above you'll see ReGenX coil operation, and I'll explain why that's happening. Okay. All right. And this coil, this configuration, the coil delivers about, I think it's about 3.5 amps in this configuration. Oh. You need coil lights. You're going to come in and these guys are going to stay there. Okay, so we're not going to use the tachometer on this one, simply because we don't really need it. What you're going to see in regenerative acceleration mode, you're going to see the prime mover input's going to go down, and then when we're operating below the critical minimum frequency for the coil, you're going to see regular generator coil operation. When I place it on load, it's going to go up. The input to the prime mover is going to go up, denoting that the prime mover is adding more mechanical power to the drive shaft. 3.1 amps. Everything is the same. I'm going to do it again. That's pretty close. Okay?
It's gonna stall it right now.
Yeah, it's going to stall. So the point of this part of the demonstration is to introduce you to critical minimum frequency that's going to be important later on. Okay?